Moving on from the Carbon Light project, I'd like to know what have been some of the other significant projects with which the AECB has been involved.
Well, as well as successfully funding Carbon Light, the AECB also secured funding from the Esme Fairbairn Foundation. This was to carry out a comparison of the UK Standard Assessment Procedure, SAP, version 2005, with the Passive House Planning Package. Primarily, we wanted to better understand the issues associated with lower energy building design, assessment, regulatory and other aspects of compliance. Our study found that SAP made many assumptions that resulted in a less accurate model for low energy buildings. It assumed inefficient practices in terms of internal gains, ultimately resulting in an underestimation of heating requirements. Now, these shortcomings are of course understandable given SAP's development as a tool for modelling existing houses, compared to PHPP, Passive House Planning Package, which has been developed specifically for very low energy buildings. For example, in a poorly insulated building, energy consumption is highly dependent on how you control your heating system, which is an area well developed in SAP.
What do you find about PHPP? I mean, I'm particularly interested, you mentioned internal heat gains there and how SAP deals with them. Interested to see how PHPP, what you found, how PHPP deals with that, and also how heat losses, say for ventilation and infiltration, are dealt with in PHPP.
In passive house design, solar gain can provide more heating energy than the actual heating system, so PHPP includes accurate analysis of windows and shading. Air, for ventilation, can be a major heat loss in a well-insulated building, so passive house designs incorporate heat recovery ventilation, which PHPP models carefully. SAP, on the other hand, has traditionally estimated heat loss due to ventilation purely on the leakiness of the building. SAP next assumes that occupants in a more airtight building will be able to maintain steady ventilation by opening the windows. By the way, PHPP doesn't try to model natural ventilation. Well, in terms of differences found, the most significant differences found perhaps in terms of heating demand was the level of internal heat gains assumed. Whereas PHPP, for example, expects higher standards of energy efficiency, SAP is still working on the assumptions of tungsten light bulbs and inefficient appliances. In terms of limitations that PHPP may have, particularly in the UK context, these are issues that the early adopters, particularly AECB members active in, like yourself, in fact, using PHPP in their projects, we are learning rapidly, and limitations and other issues will be explored as and when they arise. Specifically, perhaps PHPP may appear to underestimate electrical use in many cases, but the point here is that it is being used to design an efficient building fabric. The fabric continues to be effective as energy efficiency improves concerning appliances and lighting, for example. By assuming high internal gains, SAP gives the designer the message that insulation beyond a certain level is pointless, as the house is perfectly well heated by all the internal gains. And this prompt to designers from SAP has been taken to suggest that heat recovery ventilation is not worthwhile. But when you reduce the internal gains figure, passive house design standards do make sense. We presented all our findings to the author of SAP, and so the AECB has helped improve the UK calculation methodology as a result of this work. It's worth noting that the politically weighted issue of the CO2 coefficient adopted by SAP for electricity has also been influencing important decision-making around the use of electric resistance space heating and water heating, for example, and decisions about the extent of on-site generation of electricity.
That's an interesting point about CO2. I'm sure it's something that will continue to be technically and politically debated for some time. I'd like to move on now. We've kind of talked about energy use in buildings, and look at other resource use, in particular water, as I'm aware the AECB has a water standard that they've published. And I was just wondering if you could touch on that in general, but then a couple of points specifically. One, quite interestingly, probably for many people, there's nothing to do with rainwater harvesting in the standard, and I thought if you could just touch on that briefly, that would be helpful. And also, kind of briefly mention and go through where you think the code for sustainable homes water approach could be improved, or what your findings were in developing the water standard on the code.
Yes, as you said, Eric, we have recently launched the AECB water standard. The standard was based on a common sense approach to water efficiency, and we are promoting it as an alternative both to the Code for Sustainable Homes section on water and the Building Regulations Water Use Calculator. The standard itself can be downloaded from the AECB website. Now, on your question of rainwater harvesting, there is no requirement for extensive rainwater harvesting, and this surprises some people. It doesn't include this requirement since AECB early adopters realised that in most situations the water utility companies are actually doing a more efficient job of delivering rainwater to taps than individual households can. And of course, when there is a weather-related water shortage, all those domestic rainwater tanks will be empty anyway. However, don't forget your rainwater butts for irrigating the garden and washing the car. Now, for an example of how the CSH approach could be improved, consider the way the Code for Sustainable Homes allows the notional savings gained from rainwater toilet flushing to be offset against increased shower and bath water use. Shower and bath water use is, of course, the heated, high-carbon hot water.
So you just discussed a couple of key areas where the AECB is working in addition to the kind of carbon light program, the I suppose study of the passive house planning program in SAP, and also the water standard. And I've also recently noticed that the AECB is involved with a kind of international group that promotes the passive house building methodology. I just wonder if you tell me a little bit about that.
Yes, the AECB is an active participant in this EU-funded project. PassNet stands for Passive House Network, which aims to promote passive house methodology and standard within each country, the AECB and the UK partner. It's a pan-European network of passive house promoters, and as a result, we've extended our network and gained further valuable insight and experience from our international partners. This project is creating valuable, productive relationships with international partner organisations right across Europe.
Moving from a European-wide issue and organisation to a UK-based competition, actually, which I think many people will probably be aware of or have been involved with, including myself, which is the Retrofit for the Future competition put on by the Technology Strategy Board. I know the AECB was involved in helping develop that, and I just wonder if you could tell me a bit about that.
The AECB has been advising the Technology Strategy Board as part of this Retrofit for the Future competition. As a result of this initiative, almost 90 housing association low-rise homes are going to be retrofitted with packages of integrated measures, all aiming for an 80% whole home reduction in CO2 emissions. During phase 1, 200 design teams worked with housing associations and carried out feasibility studies into their chosen properties. Project teams have just recently submitted for phase 2, and we now know which projects have been taken forward to realisation. In many ways, the Retrofit for the Future competition is one of the most significant projects the AECB has been involved in. If we have successful and scalable solutions stemming from this initiative, they could have a profound effect on both our understanding of low energy refurbishment, and we hope that these results will intelligently inform government policy. It would be nice to think as well that successful projects will raise UK citizens' expectations and their aspirations in the context of rising energy costs, decreasing comfort levels, and of course greenhouse gas emissions.
Yes, it'll be interesting to see the outcome of the retrofit projects and how they kind of develop over the next couple of years.